2.6 large sample approximations to sampling distributions. Sampling distributions play a central role in the development of statistical and econometric procedures, so it is important to know, in a mathematical sense, what the sampling distribution of big Y bar is. There are two approaches to characterizing sampling distributions: an exact approach and an approximate approach. The exact approach entails deriving a formula for the sampling distribution that holds exactly for any value of n. The sampling distribution that exactly describes the distribution of big Y bar for any n is called the exact distribution or finite sample distribution of big Y bar. For example, if big Y is normally distributed and big Y sub 1 through big Y sub n are independently and identically distributed, then, as discussed in section 2.5, the exact distribution of big Y bar is normal with mean mu sub big Y and variance sigma sub big Y squared over n. Unfortunately, if the distribution of big Y is not normal, then in general the exact sampling distribution of big Y bar is very complicated and depends on the distribution of big Y. The approximate approach uses approximations to the sampling distribution that rely on the sample size being large. The large sample approximation to the sampling distribution is often called the asymptotic distribution. The asymptotic because the approximations become exact in the limit that n approaches infinity. As we see in this section, these approximations can be very accurate even if the sample size is only n equals 30. Observations, because sample sizes used in practice in econometrics typically number in the hundreds or thousands. These asymptotic distributions can be counted on to provide very good approximations to the exact sampling distribution. This section presents the two key tools used to approximate sampling distributions when the sample size is large: the law of large numbers and the central limit theorem. The law of large numbers says that when the sample size is large, big Y bar will be close to the mu sub big Y with very high probability. The central limit theorem says that when the sample size is large, the sampling distribution of the standardized sample average open big Y bar minus mu sub big Y close over sigma sub big Y bar is approximately normal. Although exact sampling distributions are complicated and depend on the distribution of big Y, the asymptotic distributions are simple. Moreover, remarkably, the asymptotic normal distribution of open big Y bar minus mu sub big Y close over sigma sub big Y bar does not depend on the distribution of big Y. This normal approximate distribution provides enormous simplifications and underlies the theory of regression used throughout this text.